Okay, so I'm going to talk about the A in Jamstack. So as you all know, as you all love, the fact is that Jamstack is made up of kind of three broad categories of things: JavaScript and different JavaScript frameworks, markup, and the support for markup with static site builders and others, and of course the big A in the middle, which is the APIs. The APIs that allow you to hydrate your either your static content or your dynamic content with stuff from various backends, for example, Auth0 or Cloudinary, where Tessa works. So what I'm going to talk today is about what is the role of that APIs and how can we make the A in API in Jamstack to be actually a very first class citizen. So APIs are used during static builds that many of you have are using today. So you may be actually building your static content. If you're building an e-commerce Jamstack site, you may be picking product information from Contentful. Price perhaps doesn't sit in Contentful; it sits in some MySQL, and reviews may come in Mongo, and you're using either APIs or some direct connects to get information, and then you're going to actually do kind of static pages built out, and then you deploy it. But then at runtime, from the browser, you want to actually support access to dynamic content, and that is where other sets of APIs may come in. You may have an API that determines the location of where the user is, and therefore you may want to connect with IPAPI, which is a very good API for determining the locations based on IP address. You may want to tailor your message based on weather, therefore you may be connecting with Open Weather Map, or you may want the latest inventory available to you, which is different than what are the static builds. So APIs play a role both during static builds and in dynamic builds, and that I think is fundamentally important to actually really succeed with Jamstack. Now, there are lots of APIs. Each API behaves differently. There is kind of different syntax. There's different authorizations. There is different ways in which response comes back. And then you also have to do a lot for each of those APIs. So for example, if from a browser you want to call an API, you need to be able to protect the key for that API, because obviously you don't want the key to actually leak into the browser. You want to ensure that the query that the browser is executing doesn't get modified in the browser. So for example, if you have an API that allows a request which is what is available for sale given a month, you don't want somebody to go and manipulate the month parameter in the browser, and suddenly they can find out what products will be available for sale next month, and that could leak kind of competitive information. So the way you do this is you write kind of some Lambda functions or some other serverless functions, then you deploy it and you maintain it in order to kind of take care of one API. And then you've got to do this for the second API that you've got to deal with. Its key has to be protected, its query has to be protected. So you write more Lambda functions and you deploy it, et cetera, et cetera. So in order to kind of make all of this API stuff work in the Jamstack environment, you're doing a lot of manipulations of the APIs, even if those APIs are available to you. And that's not all. You've got to kind of handle errors, you've got to handle caching, expired keys, et cetera. So you've got to kind of take care of a lot of these things for APIs to become a full first-class citizen of your Jamstack stuff. So we have just written a blog on this. You guys should go and check it out on all the things that you've got to do in order to take care of some of these things that you want to hide or protect from your stuff. So when you get a chance, do check this out, which is in the blog section of StepZen.com. But then there are other things that you need to do with the APIs. You need to kind of stitch APIs together. If something happens, then call this API, otherwise call this API. You want to cache if the backend is not responsive. If you've got like 800 milliseconds to respond back, and if the backend is not responsive, then you've got to kind of set up a cache in order to make something work. You have to monitor whether your key has expired or not expired, because otherwise you're going to give suboptimal functions. So now you write more Lambda functions and you kind of deploy it and you maintain it, et cetera, et cetera. So your work, in order to really make kind of API world story work, there's a decent amount of work that you need to do to kind of both build and manage and protect yourself. We believe that GraphQL is a natural, given that there are so many APIs that you deal with, GraphQL is a natural API of APIs. GraphQL allows, kind of says that different backends and different ways of connecting to the backend can all be made uniform in the context of a GraphQL endpoint. And therefore, you can kind of fetch a customer information and her orders and the delivery status all with one GraphQL API. So therefore, in our mind, this API problem associated with Jamstack needs to be solved with GraphQL. But in order to be able to use GraphQL, of course, you need to be able to, it should be very easy to set up. You should not get into all the complications with backends. You should be able to abstract away the SQL, the NoSQL, the REST, the GraphQL backends, whatever backends you have that you need to be able to kind of stitch things together as Tessa was talking about. And so that's really, really important for you to be able to leverage the power of abstracting the backend APIs away. But in addition, I told you a lot about some of the runtime problems. Therefore, you also probably need something as a service that kind of takes this GraphQL concept and stores the keys safely, manages access control, monitors the backends for performance, parallelizes the execution, and is always on, so that your customers who come to your Jamstack app can depend on the fact that this stuff is always on and is always available. And if this can actually be made to happen, then you can use the same concept for static builds as well as for dynamic builds. Now, there are many providers out there, kind of just general class of problems that I talked about. There are many people who are trying to solve this for all of you developers. Apollo is there, Hasura is there, GraphQL Mesh is there, etc. I'm not going to talk about what they do and they don't do. You should all check it out. But we have got kind of a unique take on how we do it and how easy we make it for you. And therefore, I'm going to talk to you about how this overall problem of APIs and making APIs to be really accessible and always on, and for them to protect your keys and everything else is solved using StepZen. So our mantra is that you as a developer have to worry about a lot of things, and therefore, how easy can we make it for you to be able to get a live GraphQL endpoint? So can you pick something from a public repo that we have, for example, at StepZen, mix and match it with some private repo of GraphQL snippets, combine them, and then deploy them, and you get a live endpoint. And we'll actually show you, Anthony and I will show you how you can that easily do it. That's what we want to get to. We want to get to kind of reducing the friction of you building and leveraging GraphQL in your Jamstack environment, because we believe that with GraphQL, you get a huge amount of benefit with respect to all the API stuff that you've got to do. So in our world, the way this is actually done is that you define interfaces, which is how your application wants to see the data. Okay? You connect the backends with the data. Sometimes there is only one backend for a particular interface, in which case you can skip the interface and just deal with the backend. And then you link interfaces together. You write basically these simple GraphQL snippets from scratch, or as I said, you just do StepZen import from a private repo or from public repo. You can upload and deploy these assets on StepZen so that it's an always on live endpoint, or I'll show you how you can actually use StepZen start to actually automatically monitor it. So in today's demo, what we'll do is we will actually do StepZen import, which will pull, and a StepZen start, which will kind of watch and deploy. So you'll always have a live endpoint as you build up more and more complexity into your GraphQL system. So what we're going to do, if the demo gods are good with us, okay, we are going to take an application that Sam and Anthony have built, which is a very, very simple application, which is a post-login application that will show for a customer what her orders are and what the delivery status and a few other things are. And some of that is dynamically built and some of that is statically built. And then after Anthony has shown you what the front end is, I'm going to come back and I'm actually going to build the endpoint GraphQL endpoint with this kind of imports and starts, and you'll see how easy it is. That kind of assembles all of this information together that Anthony uses. And of course, I'm going to build it on a different endpoint than the endpoint that Anthony has built. And then if everything works well and the demo gods are smiling on us, Anthony will redeploy the application with that new endpoint that I just created, and hopefully everything should work.